Hello, welcome to another video. This is Natural Sciences for University, by the way. We are now looking at the introduction to physics. This is one of the questions coming from Rotational Dynamics. It says a block of mass m, 2.5 kg, falls a distance 2.20 meters while unwinding from a frictionless uniform pulley of radius 10 centimeters and mass 1.5 kilograms. As this figure shows. Determine the tension in the cord, the acceleration of the block, the speed of the block after falling 2.2 meters, and the rotational kinetic energy of the pulley after the block falls 2.2 meters. All right, so let's just gather the data first before we even go anywhere. It's very important. So we can gather our data here. So we have the mass of the block, let's call it MB. Mass of the block is just 2.5 kilograms. What else do we have? We also have the distance, which the block falls. It is actually 2.2 meters. Then what else do we have? We have the radius, which is given by this, which is 10 centimeters. And we know that distance shouldn't be in centimeters, so we divide by 100 to give us 0.1 meters as the radius. What else do we need? We have the mass of the pulley, so let's call it MP. All right. So in fact, small letter m is for the mass of the block. Then capital letter M is the mass of the pulley. All right. So the mass of the pulley. So just to make the question easier, let's say MB for the block and MP for the pulley. All right. So it is 1.5 kg. I hope we're moving together. All right, then because it is rotational, when this block is falling, right, this thing, the pulley is rotating clockwise like that. Sorry, and clockwise, it's rotating. Because of that rotation, it encounters a rotational motion, which implies that since the pulley is uniform, it has what we call the moment of inertia. So we need to describe what our moment of inertia is. Now, the moment of inertia for a uniform pulley is actually given by half mass. Now, this is the mass of the pulley. We call it MP. Then multiplied by radius squared. This is what we need. Okay. So, and of course, gravity, we are going to use 9.8. We need it. Given this information, we can now come up with two equations. Remember, we have the motion due to this and the motion due to the entire pulley, meaning we are going to have two equations. So let us set up those two equations together. All right. So coming to the setting up of equation, we are going to use, of course, Newton's second law of motion is what plays better here. So let's start with the block. The block is moving in this direction. We are calling it the y direction. Can we call it the y direction? It's fine. All right. Meaning, if we apply second law of motion here, the sum of forces in the y, all right, is just equal to mass multiplied by acceleration. Now, this mass is the mass of the block. So we are going to call it mb multiplied by a, because I've already said MB, it will represent what the mass of the block, to make sure that we differentiate clearly there. Right now, here's what we know. We have an arrow here giving us the mass. Therefore, this one will give us the mass of the block multiplied by gravity. This is a weight, and here is a tension. So because the block is going down, the weight is pulling the block down, the weight is bigger. So we have B multiplied by what? Gravity minus tension here, which is going up. This is equal to MBA. This is our equation number 1. All right. Now let's do the same for the pulley. Now for the pulley, it is undergoing rotational motion. Because it is undergoing rotational motion, it is accompanied by what we call torque. All right. So the torque is what is causing the turning. This is turning because there is a torque there, and the torque is given by R multiplied by the tension. because this tension multiplied by the radius will give us the torque. All right, I think this formula we all know, where T is just the force. Now, just there. Now, we know that this torque, it causes what we call an angular acceleration. So as this is moving, of course, there's a torque somewhere, but this also causes an angular acceleration. Because it causes an angular acceleration, we also know that torque is equal to in moment of inertia multiplied by angular acceleration. This is why we needed this to be found first. So this is another formula. So we know that torque is equal to R times tension, but also that torque is equal to moment of inertia multiplied by angular acceleration. So we can now make a substitution. Where there is this, we just put angular in moment of inertia, angular acceleration is equal to RT. Is it clear, right? All right, so meaning that we know what the moment of inertia is, isn't it? We know what the moment of inertia is. It is just half there. So if we do the substitution, we're having RT is just equal to half mass of the pulley R squared. Then we have, let me do this, we have the angular acceleration there. So this R will cancel with one R there. Okay, but at the same time, we know that there's a relationship between acceleration and angular acceleration. Do you know it? Yes. Acceleration is just equal to radius angular acceleration, meaning my angular acceleration is equal to acceleration over r. So once I do that, I come and place represent it there. Mass of the pulley r squared. Then here I've got a over r, of which now we can cancel out and we get our T, giving us half mass of the pulley then acceleration. This is our equation number 2. So now we have two equations, this one here and that one there. We are now ready to go. Remember, we shouldn't forget our goal. Our goal is to find the tension and the acceleration. This is why I made acceleration here, so that we can have it appear somewhere in the equation. The tension is there, meaning we are safe to go. Therefore, all right, so we now have only two equations. So our equations now, let me just define them here. Once we define the equations, everything becomes simple, by the way, trust me. We have our equations mg minus t. Okay, this is the mass of the block multiplied by gravity, which is giving us weight, is equal to the mass of the block multiplied by acceleration. And the other one is T is equal to half. This is the mass of the pulley multiplied by the acceleration. These are the two equations that we're going to use, especially to answer part A and B. All right, now we can we know what tension is, right? We can substitute in the first equation so that we can come up with acceleration. All right. All right, so meaning that if I substitute tension there, I'm having mass of the block multiplied by gravity, then I'm going to have minus 1 over 2. I'm going to have mass of the pulley multiplied by acceleration is equal to mass of the block multiplied by acceleration. All right, of which, of course, I can group them together, giving mass of the block multiplied by gravity is equal to mass of the block multiplied by acceleration plus half mass of the pulley multiplied by acceleration, which will just give me so now acceleration will be equal to mass of the block multiplied by gravity over, I factorized the acceleration here, meaning I'm going to remove the mass of the block plus half mass of the pulley. This is going to give me acceleration. Let's find it, in fact. So this will give us acceleration. So we get part A and part B simultaneously. So if I plug in everything there, let's do that. Mass of the block. What do we find as the mass of the block? I think we have it somewhere there. 2.5. So we have 2.5. Then gravity is 9.8 over 2.5 there plus half 1.5. So acceleration is equal to, let's keep on punching please on the calculator. All right, if I punch on my calculator, I'm getting 24.5 over, this is just 2.5 plus, that's just 0.75. So my acceleration now is equal to 24.5. Adding these two, I should be getting 3 point something, which is 25. So this means that my acceleration is just equal to 7.54 meters per second squared. So we now have the acceleration. What is now the tension? Now we can find tension using this equation number 2 here. We know that tension is half MPa. This would be half mass of the pulley. What's the mass of the pulley? 1.5. And the acceleration is 7.54. Let's get our calculators, please. So I'm getting 5.66, which is just 0.6. Yeah, can you just leave it to 7? It's fine. Newtons. That becomes our tension. Now, to answer part C, everything is simple now. Part C is asking for the speed. For us to find the speed, we can use V is equal to U plus 2AD. You know this formula, squared, sorry. We're looking for V squared is equal to initial velocity 0, to acceleration is 7.54, the distance is 2.2. So our V squared is just equal to 33176. I'll round it off to that. Square root. Of course, just get the positive part of this one. So let's quickly. So I'm getting 5.76 meters per second. That's the speed. What about D? D is asking us to find the rotational kinetic energy. So it's asking us to find the rotational kinetic energy. Ke rot, meaning rotational kinetic energy. Now, rotational kinetic energy, okay, Ke rot is equal to half moment of inertia multiplied by the angular speed or velocity. And we know that V, the relationship between the linear component of velocity and the angular one is just V is equal to this R, meaning our angular velocity just V over R. So if I replace it there, and we already know the moment of inertia, I. So this one I'm going to replace there. Then, but it's being squared. So if I square this one, I'll be having V squared over R squared. Good. Then I need to find moment of inertia is half. Okay. Mass. This is the mass of the block multiplied by the radius is squared, if I'm not mistaken. Or MP, sorry, not MB, but MP. MP, then radius is squared. Yes. Hope I did the correct thing. Okay, yeah, fine. Then we can just work it out. So we have got half, and there we have moment of the pulley. So the mass of the pulley is 1.5. Then the radius is 0.1. We square it. So can we fail to find what? Let me confirm again. Okay, 1.5. Thank you. So now let's evaluate that one. So I'm getting 0.0075. Of course, it's kg meter squared. That's our moment of inertia. Now, can we fail to find Ke rotational? Half I, this is squared. So we only have one. This half has already been found. So 0.0075. Oh, there's already a half here again. I again has got half, so the half is still there. Then there we are putting, all right, we are putting, okay, V was 5.7, so 5.76 over radius is 0.1. Then that is being squared. Everything is being squared. Okay, let's punch now on the calculator. Now, look, what I found here actually was that I already expressed this in angular form, right? So in linear form. So you can even actually keep it or maintain it in your angular form. It is still fine. But if I get 5.76, I divide by 0, I square that one, divide by 0.1 squared, and I multiply by 0.0075 and divide by 2. I'm getting 12. It's the same thing. You are still going to get the same answer. Getting 12.4 joules. So this is how this question was supposed to be tackled, and I hope that you people have enjoyed this video. Please subscribe and share the link to others so that they can also learn. It's been PVS the tutor, and this is, of course, the channel we are watching from, Natural Sciences for University.